Hi, I'm Zach Ryan. I'll be your instructor for today, and today we will be learning how to balance equations. Balance equations is a simple step which is a basic building block for all chemistry. Now, we'll start off simple with a small equation, and then we'll work up to maybe a more complex equation in the end. So let's start out with a combustion equation with a substance called methane, which is CH4, a hydrocarbon. Now, with all combustion reactions, you have the hydrocarbon and oxygen making carbon dioxide and water. So to start balancing equations, what you want to look for is something that's only in one place on both sides. Now, in this equation, that only seems to be carbon. So the carbon, you have one carbon on this side of the equation and one carbon on this side of the equation. It's nice to keep a little list to make sure, especially for equations, to keep track of what you've already balanced and what is balanced already. So let's move on to something else, like hydrogen. You have one spot where hydrogen is here and one spot where hydrogen is here. There's 4 hydrogens on this side and 2 hydrogens on this side. These aren't equal, so you have a problem. There aren't equal atoms in the equation, including to laws of thermodynamics. You can't lose this matter. So we have to double the amount of hydrogen here to get it to evenly match up. Alright, so now your carbons are balanced, your hydrogens are balanced, and so the only atom left in this equation to balance is oxygen. So on this side you have 2 oxygens, because O2. On this side you have 1, 2, 3, 4 oxygens. Now this is also, again, unbalanced. To balance this, we would put 2 right here. 2 times 2 is 4. And you end up having 4 oxygens and a complete balanced equation. Now from this balanced equation you can do conversions with moles to grams, anything of that sort. Let's try another combustion reaction. These are always easy to start with because you can determine the products quite relatively easy and know what is going on. So let's do a combustion of a little bit of a bigger, more common hydrocarbon. Propane, C3H8. And again, we are adding oxygen, and that is going to make a certain amount of carbon dioxide and water. Alright, well first off, we know again that carbon is only in one place in either equation. Now to balance, we have 3 carbons here and 1 carbon here. To balance this, simply put a 3 right here. You triple the amount of carbons on this side to match what is on this side, and the carbons are now balanced. Next step, hydrogen is also in one place. You want to do these first because if you try and balance the oxygen, which is in multiple places, you can get into a bit of a hairy situation, and the equation can be harder to balance. So let's balance the hydrogens now. So you have 8 hydrogens on this side and 2 hydrogens on this side. This is H2, multiply it by a coefficient of 4. And congratulations, the hydrogens are balanced. Now, the last step is the oxygen. So you have 2 oxygens on this side, and 6, 10 on this side. So, 10 oxygens. Now, to get to this 2 to a 10, you multiply by a simple coefficient of 5. Double check. 3 carbons, 3 carbons, 8 hydrogens, 8 hydrogens, 10 oxygens, 6, 10 oxygens, and your equation is completely balanced. For our final equation, we'll try something a little more complex this time. We are going to do a reaction. It's a kind of a combination of multiple types of reactions, as you can see. Alright, well first off with this equation we're going to want to see what's on each side only once. And from looking at it, the first thing you notice is copper is on each side only once. You have 2 coppers on this side and 1 on this side. Easiest way to fix this, put a 2 right here. We have and now we have the coppers balanced. Alright. The second thing that is only in one location would be the iron, Fe. Alright. So we have 2 Fe's thanks to this coefficient right here, and then 1 Fe right here. We put a 2 right here. We now have 2 irons here and 2 irons here. Now, everything else is in multiple locations at one time. So if we look at sulfur, it is in here and here. So this can take a little bit more work to balance. So right now we know we have 4 sulfurs on this side. And we have 1, 2 sulfurs on that side. So let's leave that alone for right now, and we'll move on to the oxygens. So we have 2 oxygens on this side, and we have 3 on this side. So these are obviously not equal. So what you're going to have to do is we're going to have to look at everything all together when we look at both the sulfur and the oxygen, because we have to balance those things at the same time. So to start balancing the sulfurs and the oxygens, we're going to want to look at the copper 2 sulfur, alright? Yeah. You have 2 coppers here, and we don't want to mess with the coppers again. So we're going to actually, to balance the sulfur, we're going to put a 3 right here, which will give us 4 sulfurs. That also changes the amount of oxygens that we have, but as I said, we have to balance these things at the same time. So now we have 8 oxygens on this side, and only 2 oxygens on this side. Well, that is easier for us to balance, because if we put a 4 right here, we end up with 8 oxygens. So as you can see, our equation is now completely balanced. I hope you enjoyed this instructional video, and have a nice day.